Hello students, today we will study questions of thermochemistry. Okay, so let us start our class. So what we will do today, so it will practice question from 8 to 14. So that will comprise of total 7 questions. So for each question you will be given 10 seconds, and at the same time when I read out the question, so I give you this kind of time to so that you can get your question, because it is difficult to solve question in 10 seconds. So I will give you extra time while reading, because I read out it slow, and and then can just check your answer. I will give you the answer plus the solution, that how you can solve it. Okay, so let us to start our today's session. Disclaimer: the images used on our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owner of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. First question, question number 8. The heat of combustion of carbon and carbon monoxide are minus 393.5 and minus 283.5 kilojoule per mole. The heat of formation in kilojoule for carbon monoxide per mole is, so the options are A 676.5, B minus 676.5, C minus 110.5, and D plus 110.5. So what is the hint for this question? So first of all, you should focus on the unit that you have to find your answer in the kilojoule. Okay, and second thing, you should know that what is the definition for heat of formation. Okay, so we are writing that, okay, we have to find the heat of formation for carbon monoxide. So just try to write the equation for the heat of formation and just try to get it from the combustion equation, that is having whose enthalpy values are already given. Okay, so you have 10 seconds to solve this question. Your time starts now. Okay, so the time is up. Now let us see how we can solve it. So the question is saying that the combustion for carbon and carbon monoxide is given. It is given for per mole and in kilojoule. Next, what you have to find, you have to use this two enthalpies or heat of combustion and just rearrange them so that you can get the heat of formation, and that is also in kilojoule. Okay, so you have to find it for carbon monoxide, and here it is also written that you have to find it for per mole. Okay, so for those who have solved, the correct answer is C. Now we will write the combustion equation for the carbon first of all. So carbon standard state, it is in solid. Good. Then we take the oxygen, which is in gaseous state, again in the standard state, and which gives us CO2. So this is the combustion equation, very simple. So its value is given as minus 393.5. So we have written it as it is and taken it as equation 1. Now next in the combustion of carbon monoxide, so this is CO, carbon monoxide. So its combustion also produces CO2, and again its enthalpy of combustion is given, or heat of combustion is given, which is minus 283.5 kilojoule per mole. Remember that you have to keep the coefficient of the one undergoing combustion as 1, because this is given as, this value is for per mole, and same goes for this thing. Now you have to say do the subtraction and addition such that you get the heat of formation, or the equation for the formation of carbon monoxide. So for that, what we have done is we have subtracted 2 from 1. Okay, so what we will get? So if you just subtract 2 for 1, this thing will be as it is. Okay, this thing will be as it is. Now we are subtracting equation 1, so this equation will get reversed. Okay, so CO2 will come on this side and the reactant will go on this side. Now keeping that in mind, we can just what we can do, we can subtract 1 minus half, so that will give you half O2. And second thing, this CO2 and CO2 will get cancelled out. Okay, so this is very simple to understand, that CO2 and CO2 is getting cancelled out because we are subtracting equation 1 from 2. So which will bring you to this equation. right? Okay, so moving on further, we will do the same thing with the enthalpy what we have done with the equation. So 2 minus 1 would give you what? So this is 2 and this is 1. So that will give you what? This will give you minus 110 kilojoule per mole. Okay, so we are subtracting 2 from 1. Okay, okay. So we don't reverse this equation. We reverse this equation. Okay. Okay, sorry for that. So what are we doing? We are reversing this equation. We are bringing this thing here and we are bringing this whole thing on this side. Anyways, so you get the point, right? So what we have to do, we have to rearrange these two equations such that you get your answer. Now value is again in kilojoule per mole, and you should not forget to get the units right, or you will get your answer wrong. Okay. Now next question. Question number 9. If the enthalpy of formation of C2H4 gaseous, CO2 gaseous and H2O liquid at 250 degrees Celsius and 1 atm pressure are be 52 minus 394 and minus 286 kilojoule per mole respectively, the enthalpy of combustion for C2H4 gaseous will be, your options are 1412 kilojoule per mole, option A; B minus 1412 kilojoule per mole; C plus 141.2 kilojoule per mole; D minus 141.2 kilojoule per mole. Now what will be the hint of this question? Again, what you will do, you will first of all write the enthalpy of means the equation for formation of these three, right? And now you will rearrange such that you get the combustion of the C2H4. And how will be the enthalpy of formation written? So you will take the elemental form of these two elements for the C2H4, for these two of CO2 and these two of H2O, right? And you will take their standard state. Now what will be the case for combustion? So for combustion, you will burn this in the presence of oxygen, and that will give you CO2 and H2O, right? Okay, so you have 10 seconds to solve this question. Your time starts now. So your time is up. Let us see the solution. Let's see how we can solve it. Now the question is saying that you have to use these three informations, which is basically the formation, which is the enthalpy of formation for CO2, H2 and C2H4, and you have to use these three equations and rearrange them accordingly so that you can get the equation for the combustion of C2H4. Okay, and as I already told you, for the formation you will take the elements in the standard state, and for the conversion you will get CO2 and H2 as the product while reacting with oxygen. Okay, now for those who have solved, the correct answer is B. How will solve it? So this is the equation for the combustion of C2H4. So first we have written this thing. So C2H4 3O2 2CO2 plus 2H2O. Now remember to balance the equation. You will never get your answer until and unless you balance it. There is no benefit without balancing the equation. So you need to balance it, right? Now how you will get this? So for that we have multiplied the formation of heat of formation of enthalpy of formation of CO2 with 2. Again we have multiplied the enthalpy of formation of H2O with 2, and we have subtracted the enthalpy of formation of C2H4 and the enthalpy of formation of O2. Clear? And that thing is multiplied by 3. Now if you do so, you will do the same. Just try to do this with the equation. Okay, so I have left this thing for you so that you can also get handy with this thing, right? So student do make mistake in the examination while dealing with this thermochemical equations. So I have written the operation here. You do the same thing with the equations. Write the equation neatly. Just rearrange them accordingly. How I have written this. Just write it according to it, and then I have done, I have just put the enthalpy value here. Okay, so this is the enthalpy value of this thing, enthalpy of formation again for this thing, and for oxygen we know it is 0, right? Okay, so you will get minus 1412 kilojoule per mole as your correct answer. Clear? Okay. Now, moving on further to the next question. So in this way, you will get your answer at B. So further moving. So on further, we have question number 10. Now question number 10 says that your heat of combustion for H2 gaseous is equals to minus 241.8 kilojoule per mole, and for carbon solid it is minus 393.5 kilojoule per mole, and for ethanol in liquid it is 1200 minus 1234.7 kilojoule per mole. Now you have to find the heat of formation for C2H5OH, which is what? So your options are minus 2747.1 kilojoule per mole, B minus 277.7 kilojoule per mole, C 277.7 kilojoule per mole, and D 2747.1 kilojoule per mole. What will be the hint for this question? So the hint for this question is that your combustion equations are given. Okay, write the combustion equation very neatly. Now use these two thermochemical equations. So use these three thermochemical equations to get the heat of formation. So how we'll get the heat of formation? On the reactant side, you will write carbon in solid, hydrogen in the gaseous form, oxygen in the gaseous form. This is O2, and you will add this equation, add this all of this, and the product side write this thing. And now you will balance the elements accordingly. Clear? So on doing this whole process, you will get the fourth thermochemical equation, which is the required one. Just sum up this all of these three, remaining these three, accordingly to get the fourth one. Right? So your 10 seconds to solve this question starts now. Okay, let us see how we can solve it. So moving on to the solution. So this is the question. First of all, how we will understand the question? So you will have to interpret the data that are given. So you are given the conversion for this, for carbon solid, and for C2H5 liquid. Right? You are given the conversion. Here you have no issues to write the thermochemical equation. So what will be the product for combustion of hydrogen? Water. Carbon, it is carbon dioxide, and ethanol will be carbon dioxide and water. Very easy to write. And for heat of formation, you will take the standard thing, or that is your carbon solid, hydrogen gas, which is already given, its combustions are already given, and oxygen also, and oxygen formation. Right. So these three are given. Now, for those who have solved, the correct answer is B. So first of all, the combustion of H2 plus half O2 written. Okay, no problem. Then this thing is for H2O. Next thing we have written for the carbon to get CO2. So the heat of formation, the formation of CO2 is also given. So you get the point, right? That the formation of H2O liquid and the formation of CO2 both are given. So this is all. So what I'm trying to say is that here we have this thermochemical equation gives us two things. First of all, the combustion of hydrogen, and second thing, the standard enthalpy of formation of H2O, because we are forming H2O from its elements in the standard state. Okay, same goes for the CO2. We have the combustion equation for the carbon solid as well as the formation equation for the carbon dioxide. Right. Now the third thing which is given is what? The third thing is your ethanol combustion. So using the equations that are given, so what will be the formation? Say what will be the combustion of C2H5OH? So it can be written as C2H5OH plus 3O2 gives us 2CO2 plus 3H2O. Okay. Now del H naught, we have put this thing here. Del H naught value is given already. Okay. 2FCO2 is given. Okay. And formation for H2O is given. And enthalpy of formation is not given. Now, what is the meaning of this? How we have written it? So for this, the enthalpy of reaction can be written in another way, which is enthalpy of formation of H2O multiplied by 3, enthalpy of formation of CO2 multiplied by 2. Just sum these two. That will get upon multiplying the stoichiometric coefficient. This is for the product side minus the reactant side. Now on the reactant side we have O2, and for O2 the formation is 0, heat of formation is 0. We have only for C2H5. Okay, and that thing we have to get. Okay, and the enthalpy of reaction is already given, which is the enthalpy of combustion. You put this thing here and just rearrange the simple linear equation to get your final answer. Your final answer should be minus 277.7 kilojoule per mole. No issues for this question. Now moving on to the next question. Question number 11. Combustion of glucose take place according to the equation C6H12 plus 6O2 plus CO gives us CO2 plus 6H2O, whose delta H is given minus 72 kilocalorie. How much energy will be required for the production of 1.6 grams of glucose? Molecular mass of glucose is given 180 U. You can write is unified mass. Your options are A 0.064 kilocalorie, B 0.64 kilocalorie, C 6.4 kilocalorie, and D 64 kilocalorie. So what will be the hint of this question? So the single hint, because this question is very new, I'm just giving a single hint that this enthalpy which is given, the equation, the enthalpy which is related to this equation is nothing but the molar enthalpy for the combustion of glucose. Now just use this information, it is more than enough to solve the question. So your 10 seconds to solve this question starts now. Okay, so I hope you have solved it. Now let us move to the solution part. So what was the question? The question was saying that you are already given the combustion equation for C6H12O6, which is glucose, and the enthalpy, molar enthalpy of combustion is also given, which is minus 72 kilocalorie. Because it is not mentioned here per mole, so don't get a wrong idea that it is not for per mole, because the equation is of per mole. Okay, that's it's that simple. Now what you have to do, you have to use this data and simply use the unitary method. Okay, so it is given for 1 mole, you and that is it means that it is given for 180 gram, because the molar mass of glucose is 180 gram. So for 180 gram combustion this value is given, so you have to find it for 1.6 gram. And since this is an extensive property, the enthalpy is an extensive property, you can simply change the values accordingly using the unitary method. Now for those who have solved, the correct answer is B. So same thing is done, right? That for 180 gram, the amount of heat that is required in kilocalorie is 72. Therefore, for 1 gram, it will be 72 by 180. Okay, simple unitary method. And hence, for 1.6 gram, you will simply multiply the value for 1 gram with 1.6. Okay, so that gives you 72 by 180 multiplied by 1.6. That is 0.64 kilocalorie. Clear? Okay. Now, moving on further. Question number 12. The heat evolved in the combustion of methane is given by the equation CH4 plus 2O2 gives us CO2 plus 2H2O, and the enthalpy for this equation is given as minus 890.3 kilojoule, and again it is for mole, for per mole. So you don't do any mistake by writing here per mole also, because the combustion in for per mole of CH4. Now what we have to find that how many grams of methane would be burnt if you want to produce 445.15 kilojoule of heat of combustion. Okay, so the thing here is given that you have to find the heat of say combustion when this much amount of, sorry, we have to find the amount of methane that will be burnt when this much amount of heat should be released. Okay, so it's an easy question. I will not give any hint. The options are 4 gram, B 8 gram, C 12 gram, and D 16 gram. So your 10 seconds to solve this question starts now. Okay, let us see how we can solve it. Again, I have explained the question, so I don't think I need to explain it again. So for those who have solved, the correct answer is B. So very easy question. Simple unitary method. So what was given? So it was given that for 1 mole of CH4 minus 890.3 kilojoule of energy is required. So what is the number of mole? What is the molar mass for one of CH4? It is 16. Okay. So for 16 gram minus 890.3 kilojoule of energy is released. So for releasing 1 kilojoule of energy, what amount of ammonia will be required? So it will be simply 60 by 890.3. Clear? It's very simple. So I have not used the negative sign because ultimately this will get cancelled out with the 445.15 kilojoule. So I have not used it. So what I was saying is that to produce minus 890.3 kilojoule, 16 gram of methane was required, or 1 gram mole of methane was required. Therefore, to release minus 1 kilojoule, 16 by 890.3 kilojoule of energy will be required. Okay, simple. Now again, for 415, you will simply multiply this whole thing. Okay, you will simply multiply this whole thing with 415.15. And upon doing the necessary calculation, you will get 8 grams as your correct answer. Okay, so this is your answer for the given question, which is question number 12. Okay, just try to solve it. Very easy. Simply use the unitary method and you will get your answer. Now, moving on to the next question. Question number 13. Question number 13 says that equal volumes of methanoic acid and sodium hydroxide are mixed. If X is the heat of formation of water and then the heat of involved in neutralization is, your options are A more than X, B equals to X, C twice of X, and D less than X. So what is being written here? That we have taken equal volume of methanoic acid and sodium hydroxide. Okay, and what is the formula for methanoic acid? It is HCOOH. Okay, or formic acid, you can also tell it as formic acid. So for formic acid, what is the N factor? It is 1. For sodium hydroxide, it is also 1. Means since equal volumes are are taken, therefore they will completely neutralize each other. Now during the neutralization, what is the main reaction? Just remember that thing first of all, and remember that this is a weak acid. Now you have enough hint to solve this question. So your 10 seconds to solve this question starts now. Okay, so I think you must have solved it. If not, so don't get worried. We will look onto the solution also. So moving on to the solution part. So the question was saying that you were say taking equal volume of sodium hydroxide and methanoic acid, and you were neutralizing this thing. Okay, so basically the thing that was given is that X is the amount of that is the heat that is required for the formation of water. So this thing is given. Now you have to see that what is the comparison between the heat of neutralization and the formation of water. So for those who have solved, the correct answer is D. So I have told you the main thing was that methanoic is a weak acid, right? So the heat of neutralization will be less than X. Why is it so? So because when this two things, that is your methanoic acid and your sodium hydroxide, they undergo neutralization. This is the equation that is being used. Okay. So if you just break this equation, you will find that it is nothing but the complete neutralization or the formation of H2O from its elemental form, from the elements in the elemental form. Okay, so this is the final equation. So the heat of formation becomes equal, means the heat of formation of water becomes equal to the neutralization reaction. But this is the general case. Why? Because apart from the heat, or means apart from the formation of water, in case of weak acid, I'm saying, okay, apart from the formation of water, there is one more thing that is going on, and for that also the energy is consumed. So in this case the energy is released, because neutralization is exothermic process, so the energy will be released. But at the same time, some energy that is released is being acquired or taken up by the methanoic acid to get dissociated. Okay, so this is the thing this is the main point here for this question. Okay, and due to that, what happens is that the amount of heat that should be released in the ideal case is not the one that we get, because um, some of the heat is used up in breaking this bond or dissociating this formic acid. So that thing is already mentioned here. That thing is only mentioned here, that the extra energy required for the dissociation of methanoic acid, the total heat during the utilization will be less than x. So due to that reason, so we can conclude that heat evolved will be less than the x value. Clear? Is it clear to all of you? So again I am repeating the thing, that the amount of heat that is released in this equation should be ideally the amount of heat that is released upon formation of water. But some of the heat that is released is used for the dissociation of methanoic acid, so the amount of heat that is released is not equal to the formation of water. Clear? So as simple as that. So in this way you will solve this question number 13. Now moving on to the next question. The next question is that when 1 mole of oxalic acid is treated with excess of NaOH in dilute aqueous solution, 106 kilojoule of heat is liberated. The enthalpy of ionization of acid is, okay, your options are A 4.3 kilojoule per mole, B minus 4.3 kilojoule per mole, C minus 8.6 kilojoule per mole, and D 8.6 kilojoule per mole. So what it is written here is that your 1 mole of oxalic acid is treated with NaOH, right? Means simple acid base reaction, and in that process 106 kilojoule of energy is released, right? So the thing that you have to get here is that since your oxalic acid is a weak acid, therefore the amount of heat that is released should be ideally equal to the formation of water, heat of formation of water. But since it is an oxalic acid, a weak acid, therefore some of the heat that is released due to the heat during the neutralization or simply during the formation of water is being consumed to break this oxalic acid. And for that reason, what happens is that the amount of heat heat of neutralization release decreases. So you have to just get that thing. If you are good with that thing, you can easily solve this question. So your 10 seconds to solve this question starts now. So let us see how we can solve it. So the question is already discussed. So you have to you what you are doing, you are neutralizing 1 mole of oxalic acid with excess of NaOH, and in that 106 kilojoule of heat is released. Okay, so you have to use this equation to find the enthalpy of ionization of the acid, because this is a weak acid. For those who have solved, the correct answer is D. Now suppose to break this H2SO4 or to ionize this H2SO4, the delta H ionization is x kilojoule. So you can see this is ionized into 2H plus CO4 C2O42 minus oxalate ion. Now the heat of formation of H2O is minus 573 minus 573.3 kilojoule, minus 57.3 kilojoule. So this is the amount of heat that is released upon formation of 1 mole of water from its constituent ion. Now I am multiplying this thing by 2 because we are getting 2 moles of H2O, as we have 2 ionizable H2s present in oxalic acid. Now for that 2 moles of 2OH minus will be used, and the amount of heat that is released is 11 4.6. So this is the amount of heat that is released. Now what is the total amount of heat that so this is the ideal case. Okay, so what is the total amount of heat that should be released? So it will be delta H is equals to x minus 114.6 kilojoule. Okay, clear? So this is 2386. So this is the multiplication of water. This is the formation of water for 2 moles of water. So why I am writing it in this way? Because the total amount of heat that is released is equals to the amount of heat that is released upon the formation of H2O minus the ionization energy. So that will give you minus 100. So this is the thing that was released. So if you put this in equation, you will get excess 8.6 kilojoule per mole. So what I would say is that the apart from the neutralization of this acid, we have the ionization of water and the ionization of oxalic acid, and for that the amount of heat required is 8.6 kilojoule per mole. So this is an endothermic reaction. So with this we have completed the question series of the today's session. So thank you for coming. Thank you.